actually, of amazing, dedicated, outstanding individuals in mission control who will oversee, plan, and monitor the mission from start to finish. So let me take you on a little tour of the payload bay. We have a video to run. We start out up in the very front of the bay is the orbiter docking system, the ODS. It has, not shown there, two tool stowage assemblies on either side of it where we'll keep some hardware. Along the sidewalls, we have the shuttle arm, and on the other side, the OBSS, the orbital boom sensor system. And again, the shuttle arm is going to be used for those TPS scans as well as the Japanese logistics module installation, the JLP installation. On the sidewall are some of those spares that we're pre-positioning. We're taking up a SSRMS yaw joint, which is a spare joint for the station arm, and two DCSUs, which are electrical distribution boxes that route power from the solar arrays into the batteries and into the station. On the opposite side, we have the MISSI 6 PEX. These are the payload canisters for the materials experiment that goes on the outside. We're actually going to put that on the backside of Columbus. On the pallet in the middle is the SPDM. That's on a Space Lab pallet. It flies in several pieces and gets assembled by our EVA crew. Behind that is the big Japanese logistics module. It actually has some heater cables that are plugged into the side of the shuttle, so the EVA crew will have to go out and disconnect those before we remove it with the shuttle arm. Behind it is another part of the MISSI payload. This is the base plate called the LWAPA that we bolt the experiment canisters to. And on the other side is the RIGX payload. This is a materials experiment that's flying. It's a rigidized inflatable getaway special canister. Basically, inside there are some tubes of material that are very flexible. They'll be inflated and then heated to rigidize them. It's a great experiment to test some structures that might have some good application for future space station or lunar habitat development. So with that, let me go ahead and start talking about the mission. We kick things off with a very cool night launch at 2:28 Eastern Time on March 11th. From Pad 39A will be the launch of Endeavour. The rest of Flight Day 1 is pretty standard orbit operations. We're going to configure the shuttle over from an ascent vehicle to an orbit vehicle, open up the payload bay doors for cooling, get the onboard network set up, check out the robot arm, a pretty standard Flight Day 1. Flight Day 2 is also fairly standard at this point. It's our TPS inspection where we bring the orbital boom sensor system out and use it to scan the leading edges of the wings to check the reinforced carbon-carbon, the RCC, to ensure that they didn't take any damage during ascent from any debris that might have been liberated. While that is going on, the EV crew will be down on the mid-deck, generally making a mess of things as they get their suits out, get them all unpacked, checked out, get all their tools unpacked and stowed, and being prepared for the dock mission. It's a very crowded mid-deck when that's going on to get all the gear that we need for the 5 EVAs that we're going to do. Flight Day 3. We have a video here to show a little bit of the overview. Again, a standard approach where we come up from behind and below. We fly the RPM, the rendezvous R-bar pitch maneuver, where we flip the shuttle around to allow the station crew to take pictures of the underside of the orbiter, checking for damage, mostly on the tile this time. And then we'll finish that maneuver and manually fly up to the V-bar, the velocity vector, where we'll then, Commander Gory will fly in for a manual approach, where we dock the same place that 122 did on the end of Node 2. You'll see here when we get in closer to the Columbus module sticking out, the latest addition to the station. So that takes us through docking. I'll hand over to Dana Weigel now, the lead station flight director.